Thank you to Brilliant for sponsoring this video. Hello everyone, welcome back to another devlog for Terra, my sandbox game about building a planet. In the wake of last month's playtest, which you can hear about in my last video, I received a ton of suggestions for small features and bits of polish, which is what I worked on implementing this past month. The game's release date is drawing ever nearer, so these final improvements really help make the game feel complete. I will share the release date very soon. We're almost there. With all that out of the way, let's get into this month's progress. The first feature I added was a tool to roughen the terrain, since one of my Discord users mentioned that creating rough terrain was very difficult. This tool was trivial to implement, thankfully. All I did was randomly place or remove voxels in the tools area. Next, I fixed the new water showcased last video. There were some strange-looking triangle artifacts, which arise due to the water being rasterized and not ray-traced. Essentially, the voxels were being sliced along the water sphere, causing them to no longer look like cubes. To fix this, I did a single-step ray trace in the water's fragment shader. It still isn't perfect, but it's a massive improvement. One of the biggest complaints during the playtest was about the game's performance. Especially, most players mentioned that the game's performance tanked when moving the camera quickly. This was thanks to the streaming system I implemented in my voxel engine a long time ago. Voxel chunks only got loaded in once they became visible, but this loading was very slow as it involved a CPU to GPU upload. Moving the camera quickly resulted in a lot of new chunks becoming visible, which is what caused the massive slowdown. So the first performance improvement I made was to completely rip out this streaming system and have all of the chunks get loaded on startup. But this, of course, didn't come without some difficulties. Once the streaming system was gone, the game finally played smoothly when moving the camera around. You might be wondering why I added the streaming system in the first place. I originally did it to reduce VRAM usage, since it meant fewer voxels needed to be stored GPU side. The planets in Terra are small enough though that they don't take enough VRAM to cause an issue, so the streaming system was useless. Another major performance improvement I made was to the inclusion of chunks for lighting updates. In my engine, only chunks that are visible have their lighting updated in a separate lighting shader. The way I sent the visible chunks to the lighting shader previously was to first mark all of the visible chunks in the draw shader, then send this buffer to the CPU. The CPU would then pick out the visible chunks and send them back to the GPU in a buffer for the lighting shader to handle. This, as you might have guessed, is very slow as it involved a lot of data transfer between the CPU and GPU. The solution, of course, was to have this buffer generated fully GPU side, avoiding the download and upload. This is a bit more complicated than it seems though, since, in the draw shader, each pixel gets processed in parallel. So when a ray hits a chunk, you can't just add it to the visible buffer, as multiple pixels will inevitably hit the same chunk at the same time and duplicates will be added. To solve this, I used atomic variables in the visibility buffer, which are special types of data used for multi-threaded programming that allow for coherent, in-order reads and writes to shared data. This means I could safely check if a chunk had already been added without encountering race conditions. Overall, the performance of the game jumped from around 130 FPS on a blank planet to now around 190. If you want to learn more about how to create optimized games and other programs of your own, then check out the sponsor of this month's video, Brilliant. Brilliant is an interactive online learning platform and is one of the best ways I know to learn math, computer science, and more. I've personally taken a few of their math courses and they really helped give me an intuitive understanding of the concepts that I just couldn't get at school. Their linear algebra course especially was a fantastic refresher and really helped me wrap my head around the difficult 3D transformations needed to make games. I highly recommend it. Their lessons are engaging and interactive. They focus on practical practice problems that help give you a real-world understanding and intuition, all while feeling fun and polished. They cover a wide range of subjects, from entry-level to advanced. If you want to make games yourself, it's a great way to learn all of the math and computer science necessary, from basic logic to advanced linear algebra. If you want to try it out, click the link in the description or visit brilliant.org/frozine to get a free 30 days. The first 200 of you to visit the link will also get 20% off the annual premium subscription. Thank you again to Brilliant for sponsoring this video. The next addition I made was a search bar to the prop menu, as well as a remove button permanently at the bottom. Then, my composer suggested that we should add a brief main menu theme, so we whipped one up quickly and it turned out great. I also added some sounds to the UI, as that had been requested for a while. I added the option to have lava instead of water. Then, thanks to a suggestion made on my trailer video, I added animations for each of the props. This was relatively simple. Since the props are made up of multiple geometric shapes, I just added the shapes one by one with some delay. I felt that the game's old Steam capsule image was pretty low quality, so I made a couple of nicer looking planets and photoshopped them together for a better one. What do you think? On one of my Reddit posts, I got this comment suggesting that I add a sort of replay system. I thought it was a great idea, so I started right away. It was pretty simple to implement, thankfully. All I had to do was record each action the player takes while playing, and then replay them on a blank planet. I got a basic version working pretty quickly. Then, I added a couple of options for the replay's rotation speed and starting position, and also the ability to have the camera automatically follow the edits. The camera following was a little bit nauseating though, so I improved it to only move when necessary. Next, I added some lightning that strikes randomly when it's raining. Then, while I was cleaning up some code, I accidentally increased the cloud's domain size, which resulted in this. Members of my Discord, me included, thought that this looked really cool, so I added some options to change the cloud settings yourself, as well as some similar options for the atmosphere. That's all I have for you this month. If you want to be more involved in the game's development, join the Discord server. I'll be holding another playtest very soon. I'm very excited to finally release this game, and it wouldn't be possible without your help. So thank you to everyone that helps out by commenting or playing. I'll see you next time.